In example 5, we have two radicals, so we're going to have to do the process of isolating a radical and raising it to a power 2 times. So it doesn't matter which radical that you isolate and get alone. You'll still get the same answer in the end, as long as you do all your math and algebra correctly. I'm going to go ahead and isolate the x minus 3. And then I'm left with the square root of x minus 3 is equal to 4 minus the square root of x plus 5. There are no like terms to combine, so I'm just going to go ahead and write that minus root x plus 5 next to the 4. And then we're going to use our principle of powers to get rid of that radical symbol. So I'm going to go ahead and square the left side so that I can remove that radical symbol, and then what I do to one side I'm going to do to the whole entire other side. And on the left side, x minus 3 is going to drop down, and on the right side you need to expand out that notation, that exponent, so that 4 minus root x plus 5 is written twice, and you are going to have to FOIL this out. On the left side, I'm just going to bring down my x minus 3 once again, and on the right side, we're going to go ahead and FOIL. 4 times 4 is 16. Then when I multiply my outer terms, I'm going to get negative 4 root x plus 5. When I multiply my inner terms, I'm also going to get negative 4 root x plus 5. And when those like radicals combine together, you get negative 8 root x plus 5. And then when I multiply my last term in my FOILing, I get plus root x plus 5 squared. Okay, so then I'm going to clean this up. I get x minus 3 is equal to 16 minus 8 root x plus 5. This 2 is going to strip off that radical symbol, so I can just write down plus x plus 5. And then I'm going to go ahead and combine like terms. I see though, before I do that, just because I really don't have a lot of space to do this problem, I'm going to end up subtracting this x to move it to the other side, and those guys are going to drop right away. So I'm going to combine the 16 and the 5 then. 16 plus 5 is 21. And I have everything distributed. I have everything cleaned up. There's nothing else I can do at this point. So I'm going to go ahead and repeat the process, and I'm going to isolate my radical that still remains. Okay, so the first thing I'm going to do is I'm going to subtract 21 from both sides. I get negative 24 is equal to negative 8 root x plus 5. Now this doesn't always work out this pretty, but I'm going to go ahead and divide off that negative 8, clean that right off my radical. What I do to one side, I do it to the other, and it works out beautifully. If you can't get a nice clean whole number over here, or it doesn't work out nicely when you divide a number off, then you can go ahead and keep that number there. And then we're going to go ahead and finish this off by now removing this radical symbol. So we're going to go ahead and square that. What you do to one side, you do to the other. And like I said, if you could not remove that 8 nicely, you could not divide by 8 and have it come out clean on the other side, you can actually leave that number on the radical when you're squaring it. You're just going to have to make sure that you use parentheses if you need to keep the number there. But it worked out nice for us that that 8 could be divided cleanly on both sides. So I don't have to do that. I don't really need these parentheses. Okay, so 3 squared is 9. And then the radical symbol is removed. And then we can go ahead and just solve and subtract. 5 from both sides, you get 4 is equal to x. And then you do have to check your answer. Well, we don't have a lot of space to do this. I'm pretty sure that it actually works. But let's go ahead and see. We have 4 minus 3 in the first radical. When I substitute in the second radical, we have 4 plus 5. And on the other side, we have a 4. Okay, so 4 minus 3 is 1. 4 plus 5 is 9. Looks good to me. We get 1 plus 3 equal to 4, and that is a true statement. So the 4 is definitely a solution.